Hi guys, I wanted to make a quick video sharing with you my understanding of how the Tesla Autopilot works and what is this all rewriting all about. So first, let's think about how we as humans we drive. So what do we do when we drive? We essentially control two things. One is the steering with the steering wheel, and the other one is the acceleration with the brake and gas pedals. So essentially, those are the only two things that we control. And when we learn how to drive, we essentially learn a set of rules, which are the rules of the road and how we are supposed to proceed and move around the road. So first, so we need to know what things are allowed and what things are not allowed to do in the road, and then we can take actions. But of course, to do that, we need to know the rules, but we also need to be able to see the context and know what's around us. We need to be able to recognize the road, where are the lanes, if there's a stop sign, if there's a traffic light, all the things that are around us. We need to be able to recognize that. Now, for us humans, that's the hard part, learning the rules and then taking the actions and learning how to control the car and how the car will respond. This other part, this is easy because we can see and we don't really think about that. We just think and that's it. That's easy. But if we try to replicate that in a computer, it's a bit different. So essentially, if you try to model a system from like a 10,000 feet view, you have two inputs. One is the rules, which is what you can and cannot do. The other one is the context, so what's around you, and then you need to control steering and acceleration. So how do you do that? The rules are easy. So in this case, it's the opposite. The rules are easy because it's just a bunch of, it's pretty much like an algorithm, a set of rules, and you can flow through the set of rules and control the actions. It takes a lot of code and it's painful to write, but you can do it. It's a deterministic problem. Now, the context, that's the big one. So how do you actually see what's around you and how do you actually recognize everything around you? That's been a hard problem for traditional computing. So what people are using now is computer vision because you actually need to see what's around you. Some people use LiDAR. That's I'm not gonna get into the discussion if LiDAR is good or bad, but essentially you need you need to be able to recognize a very complex environment. And the best way to do that is using machine learning and neural nets. So when people hear about neural nets, they are like, the neural net is the black box and the neural net does everything. But actually, I think that that's a different case. So let me show you what I mean. Right now, the car, this is a beautiful Tesla Model 3. You have 8 cameras and then a bunch of sensors and a radar and all that stuff. But this is what the car sees. So it has cameras. And then what happens, this is based on my current understanding of the current architecture of Autopilot, based on the talks by Andrzej Karpathy. This is great. I really love watching this guy talking. He's great. But he's fairly technical. So what I'm trying to share that with you here is a simplified version of that. So what happens now is we have all these 8 cameras looking what's around us. I'm showing that here as these are the cameras, and each camera has like a video stream, and that video stream gets analyzed by a neural network. And then that neural network recognizes objects that are in that camera. So objects can be moving objects or static objects or pedestrians, cars, stop signs, all that kind of stuff. So essentially now each camera is kind of like independent and is being analyzed independently. That's not entirely true. Some cameras work together to identify features and objects, but pretty much each camera, it's an independent thing. And then you have all the objects here. So now you need to combine that, and now you know what's around you. So you have your context. you know that you have identified a car, you know that it's in front of you because you found that with your front-facing camera, and maybe you found also traffic lights and things like that, and you represent all of that in a context. And this usually will be a very large vector showing everything that is around you. So that's the hard part, and that's what the neural network does. It's essentially computer vision. It's as simple as that. Now, it's not simple, but the basic idea is that the neural network only does computer vision, only finds things on the cameras. And then once you have your context, this guy here, you feed it through your set of rules. These are the rules, which is essentially an algorithm saying that, okay, have you found a stop sign? Yes. So there's a rule saying that if there is a stop sign, you cannot proceed, you need to stop. There's another rule saying if there's a red traffic light, you need to stop. There's another rule saying if you're falling off your lane, you need to steer to the other side just to keep the car center. Just a bunch of rules and control theory. That's fairly easy, straightforward. And the output of that is steering and acceleration. So that's my understanding of the current architecture of Autopilot. You have cameras, you have neural networks, they work pretty much independently, each camera, then you find a context, and then you have a set of rules, and then you then you come up with acceleration and steering. Now, there is this whole thing about rewriting Autopilot to be able to have like a 360 degrees view. And this is what I think they mean with that. So they still have the same 8 cameras, but what they do now is they do some sort of video processing where they combine the feed of all the cameras doing something, I don't know what. So now instead of having 8 different streams of video, they have only one. And this stream of video is a 360 degrees view of all your context. So all the context is in one stream of video. Now the advantage of that is that it makes it so much faster to label data, and you need to label data to be able to train the neural network later. So labeling is a big part of the process. So what they are doing now is they are combining all these 8 cameras to have only one stream of video, which is this one. And then that single stream of video will get processed by a neural network. And then the neural network will create a context. You're going to run the context through a set of rules, and you're going to come up with your output. That's my understanding. So basically this first part of the rewrite is all about efficiency and being able to label data more efficiently. But you still have a set of rules that are hard-coded here. There are advantages for that. There are also some disadvantages, but that's how it works. Now, I have been listening to Elon Musk for a while, and also to Andrej, and they are talking a lot about this is my understanding, they are talking about getting rid of the rules and essentially just have the neural network not only learn how to see, but also learn how to drive. And this is what they want to create. This is kind of like the second part. So they have cameras, they have one stream of video, they have one neural network that does computer vision and everything, and it also learns the rules of the road. So essentially the same neural network comes out with the steering and the acceleration, and you don't need an external set of rules. And that's super powerful for one big reason, that you're gonna have your drivers, people actually driving on the road right now, actually teaching the car. So you once you solve vision, the neural network is able to recognize all the objects and all that stuff. You just don't need to go and label data. And you're gonna have the people driving on the street teaching the neural network how to drive. Some people say that now they are teaching the neural network how to drive. That's not true. They are teaching the neural network how to recognize objects. So computer vision. But in the future, what they're gonna do is they're gonna have drivers drive around, and every time, like just driving, when you're driving, you're constantly labeling data. So essentially, what you're going to do when you drive is you're gonna have all the 8 cameras activated. So you're gonna have this. You're gonna be able to come up with this. You're gonna have that. And if you are driving, if you're in control of the car, you're also going to be providing this. So in the context of machine learning, this is the input, this is the output, and that's all the data that you need to be able to train this black box. This black box is going to be the neural network that learns how to drive. And that's super powerful. It's going to take time. It's going to take some time. But Elon and Andrej, they both talk about how neural networks or the software stack 2.0 are eating the software 1.0. So software 1.0 is this set of rules. Software 2.0 is just have a neural network do everything. And I'm extremely excited to see how they manage to do this. There are a lot of challenges. They are basically in the cutting edge of technology. There's no one has done this, so they essentially are learning how to manage people, how to manage teams working in one single network, how to manage the data pipelines and all that stuff, which is extremely exciting. So I can't wait to see if they manage to get this done. So anyways, that was my understanding. Yeah, let me know what you think. Let me know if you have any other information about how Autopilot works. I think this is super cool, and I just can't wait to see this in action. Thanks for tuning in, and if you like this video, consider subscribing and liking and maybe sharing it. That really